Okay, so in this video, we're looking at the Chapter 2 material and just going through a few of the questions. So in Chapter 2, we did three things. We solved linear equations, solved linear inequalities, and worked with formulas. So on the Chapter 2 review, that's questions 8 through 23. 8 through 16 are from the linear equations. 20 to 23 are solving linear inequalities, and then 17 through 19 deal with formulas. So let's look at a few of the questions off the final exam review. Okay. So when you have a problem like number 9, okay, that's a pretty straightforward one, except that the variable that you're trying to get by itself is on the right-hand side. Okay. So that's a problem where sometimes you make the mistake about what to do first. Like people will do things like add 21, but you really should be focused on getting x by itself. So it's going to involve getting rid of the minus 3 and getting rid of this 3 that's being multiplied by x. So one of the suggestions I make sometimes is just to interchange the two sides, okay, of the equation. If it's equal, it doesn't matter what side you put the whole thing on. You can't move little pieces like that, but you can interchange the two whole sides. Now, this is what we're trying to solve. Let me circle it. So what you would do is you would add 3, or could do is add 3, and then that would give you 3x equals negative 18. Remember that idea that what you do to one side, you have to do to the other. We're trying to get rid of the times 3, so we're going to divide by 3, and that's going to leave us with x equals negative 6. Okay, so that's a pretty straightforward one, other than the fact that the x was on the right-hand side. Okay, all right, then I want to look at a question from that section where you have variables on both sides, multiple variables. So let's do one. Let's look at number 12. Okay, so on that one, we had, it's 6m plus 4 minus 9, or no, equals 9 minus 5m plus 7m. See how there's multiple variables on that right-hand, or multiple terms with m's in it on that right-hand side? This one allows us to remember something really important that we worked really hard to understand. If the variable terms are on the same side, like the negative 5m and the 7m, don't forget the negative is attached to the 5m, those just get combined. So a negative 5 and a positive 7 would be 2m. Okay, so we have 6m plus 4 equals 9 plus 2m. Okay, now at this point, we have an m term on the left and an m term on the right. Okay, it really works best to get the m's together on the left-hand side. This is different than what my math lab shows, and so a lot of you really develop the idea of moving the number first. But if you'll move the variable term first, you wind up getting this 4m, something that looks very straightforward. 4m plus 4 equals 9. So now it's got that usual look, and we just subtract 4 from both sides. And then at that point, we can come in and divide both sides by 4. Okay. Now we got a fraction on this one, so that's going to make me think I did something wrong. So I can either come back up here and plug in that 5/4 and make sure that that what I get here equals what I get there when I plug it in. Okay. Or sometimes I'll just go back and make sure I copied the problem right, and then I just kind of run through and make sure all these signs are correct. Okay, yeah, that should be it. Okay, and then another weird thing that can happen, don't forget about distributing and that kind of thing. So like number 13, you just have to distribute, but then it's just like 12. Okay, on number 14, something special happens there. On 14, you wind up with, you have more than one variable term on the right. This one is tricky because you have this parenthesis with a minus in front of it that you need to remember that understood 1 you can put in front and then distribute the negative. So this becomes negative 1x plus 3. Okay. And notice when we combine our like terms, they're on the same side, so we're just combining. We get a negative 1x plus 15 here. Here we combine like terms, the 6 and the 3, and we get negative 1x plus 9. Now really, right then, you know something weird is about to happen because this always has the same weight as that. So you know how we think about that balance. These have the same weight. If you add 9 to one side but 15 to the other, there's no way that can be balanced. A lot of times we notice it when we try to get our variables together. I add 1x to both sides. The variable, that would be 0, that would be 0, and we'd wind up with 9 equals 15, which is false. Okay, this one is one that has no solution, or the solution is the empty set. Okay. All right, so that's one of those special cases. Now, had we done this, and let's say instead of being this, let's say it turned out to be negative 1x plus 15 equals negative 1x plus 15. So what if we had a problem where after we got all our like terms collected, that's what we had? Then see how at that point, if I added the 1x to both sides, I'd have 15 equals 15, which is always true, right? Always true. That would wind up being that the solution would be all points on the line. There would be infinitely many solutions. And they would be the set of all ordered pairs that are on the line. Oh, wait, I'm in the wrong. Ignore me. Ignore me. I'm in the wrong chapter for that. So if it turns out to be like that, that is always true. So that turns out to be the one that where any real number you plug in would work. So that would be all real numbers would work. And see, that's the same weight. And then if you add 15 and add 15, that's going to always be the same. So any number would work in here. Any number is what we're claiming. Okay, so number 14 is that special situation that can happen. All right. And then let's look at number 15 because it has fractions in it. We'll do it two ways. So if you have fractions, many of you got to where you were comfortable with the fraction keys on your calculator. So you can just keep the fractions and work with them. Okay. Or you can clear the fractions, which is what was the point of all of those. Okay, so we'll look at those two. Okay. All right, so if you're going to keep the fractions, you would put these together and get 1/2 x. Because, let me do an intermediate step there. Make sure you know this. See that 3x over 2? That is the same as 3/2 x. This is minus 1x. This is 1/14 x minus 6/7. I want to be sure you knew that that could be written out in front and that there's an understood 1 there. And this could be written out in front. So you can do 3/2 minus 1, and that gives you 1/2 x equals 1/14 x minus 6/7. Then you can bring your variable terms together by subtracting 1/14 x. When you do, that's gone on the right, and you have just negative 6/7. And on the left, you would do the 1/2. You would do this on your calculator. Okay? And that would turn out to be 3/7. Okay, and then that's being multiplied by x. So to get rid of it, you could divide by 3/7. Okay. So when you do that, you wind up with x equals, and then that you would do on your calculator, and it would turn out to be -2. Okay. If you do this by clearing fractions, you look at all the denominators and you think about what one number would knock them all out if you were to multiply them. The reason you're thinking that is this is an equation. So you could multiply the left side and the right side by the same thing and it wouldn't change the problem. So if you multiply over here by 14 and we multiply over here by 14, 14 would be big enough to knock out 14, but it would also knock out 7 and 2. Okay, so we're going to do 14 times the, let me change it, I want it to be in red, times the 3x over 2. We're going to do 14 times the x. We're going to do 14 times each of these as well. 14 times that and 14 times that. Okay, so 2 goes into 14 7 times. This becomes 21x minus 14x. You still have to multiply that x by 14 even though there's not a denominator because it's so important to distribute to both terms. Here the 14 would cancel out and we'd have just x. Here 7 would go into 14 twice and then 2 times 6 would give us the 12. So now we've turned it into the kind of problem we did earlier. These are like terms that you can combine. So that would be 7x. And then you can get the x over to that side because that's an understood 1x. We could subtract it. And we'd wind up with 6x equals -12. And then we can divide by 6. And we see the same end result, that x would equal -2. All right. All right, and then number 16 has decimals. I'll let you do that. Decimals aren't that hard to deal with because you just have a calculator. You do it using your calculator. Okay. All right, let's go ahead and look at the formula ones. So that's in the next video.